Okay, this is Chapter 1, Section 1, Evaluating Algebraic Expressions. What you need to know first is what an algebraic expression is, and that's highlighted for us right here. An algebraic expression is an expression that may contain numbers, operations, and one or more variables. This is different than an algebraic equation. Expressions don't have an equal signs. Equations do, because equations are equal to something. So we want to make sure we know the difference between an expression and an equation. So as we look at evaluating expressions, we're going to try it with one variable first. That's our first example. Evaluate each expression for x equals 8. So what they're telling us, that's an equation there. X equals 8. X and 8 are the same thing. So anywhere we see an x following, we're allowed to put 8 in its place. So on A, we've got the absolute value of 4 minus x plus 2. So I'm going to replace the x with an 8. I like to put a parenthesis in and then fill in the parenthesis with what I can put inside, what I'm substituting. So I'm going to put absolute value of 4 minus, I'm going to put a parenthesis, absolute value plus 2. Now I'm going to plug the 8 in. Now I'm going to do the math operations. The absolute values work kind of like parentheses, to begin with. We want to do what's inside there first if we can do that. And 4 minus 8 is something we can do. So 4 minus 8 becomes negative 4 plus 2. The absolute value of negative 4 is positive 4 plus 2. 4 plus 2 is 6. And that's going to be our evaluation there. Evaluate an expression is like simplify. If you ever see the rule simplify or the instruction to simplify and evaluate an expression, it's going to be the same thing. Now as we look at B over here, we've got square root 2 times something minus 3. Make sure my square root covers the whole thing. Now what I'm plugging in there again for x is still 8. X is still equal to 8. Plug an 8 in there. Now the square root symbol, I'm going to treat that kind of like a parenthesis because I need to do what's inside there first before I do the square root. Square root is on level with parentheses, or exponent actually. It goes with an exponent. Square roots can be written as exponents. You'll get to that in Algebra 2. But just think of them as an exponent level thing. So we're going to do those well before we do any multiply or divides. Okay, but we do have to do what's underneath the square root symbol first. So 2 times 8 is 16 minus 3. Square root of 16, what number times itself is equal to 16? Well, that would be 4. 4 times 4 is 16. So the square root of 16 is 4. 4 minus 3 is 1. And that's all it takes to evaluate an expression with one variable when you substitute. It's that easy. Now let's look at what happens if we have two variables. We have two variables. They're going to tell us what they're worth, and all we have to do is plug them in. So for A, now for x, instead of 8, we're going to use negative 3. They've changed what x is for us. Y, we're going to use 4. So 2 times something plus 3 times something. We're going to plug in negative 3 for x. We're going to plug in 4 for y. There's no parentheses. There's no exponents. There is multiplies, though. 2 times negative 3 is negative 6. 3 times 4 is 12. Negative 6 plus 12 makes positive 6. All it is plug and then follow those order of operations. On B, something plus something over something squared. X, I'm going to plug in negative 3. I got an X on top and on bottom. And for Y, I'm going to plug in the 4. Now, when there's this big divide line here, that's going to be one of the last things you do. So we want to do all of the top, and we want to do all of the bottom. So if I work on the top, no parentheses, no exponents, no multiplies, no divides, add, I do have an add. Negative 3 plus 4 turns into a 1. And on the bottom, I'm going to do negative 3 squared. Well, squared means times itself this number of times. So I'm going to take this number and multiply it times itself this many times. So negative 3 times negative 3. Negative times a negative is a positive. 3 times 3 is 9. So that's going to be a positive 9. Now I got a fraction as an answer. Fractions are okay. I got a 1 on top. I got a 9 on bottom. Nothing goes into them but 1. So that's my final answer. Now, it doesn't matter how many variables they put and how many they give you to plug in. All you have to do is take what it's worth and plug it in. Just have to remember your order of operations, okay? Your PEMDAS. Parentheses, exponent, multiply, divide, add, subtract. Okay, they say 1 grouping symbols like parentheses and other things, brackets, braces, so forth. Exponents, multiply, divide. Notice they have them together, same line. And add, subtract, same line. Because you do them at the same time. Left to right, whatever order they're in, you do them in that order. Okay, so let's go on to A here. We've got 2 times 9 times something squared minus 2 times something plus 3 times something. And then close there. 9a squared. A is 2/3. 2/3. B is a 9. And C is a negative 4. So, order of operations says PEMDAS. Look for parentheses. Well, I have a big set right here. So I have to look in there, and then I have to redo PEMDAS inside the parentheses. So are there parentheses in there? Yes, but I put them there, and there's nothing to really do inside them. So then we look for exponents, and I see one, okay? That 2 right there. So 2 on the outside stays, the big parentheses stays, 9 stays, and we're going to do this exponent. Now, 2/3 squared. Well, that's 2/3 times 2/3. Go straight across the top. 2 times 2 is 4. Straight on the bottom. 3 times 3 is 9. It's 4/9. That's good. We want that. That looks nice. We can do this multiply because there's no more exponents behind us, but there are multiplies. 2 times 9, 18. 3 times negative 4 is negative 12. Now we get to do the multiply of the 9 times the 4/9. Well, when you multiply fractions, again, you just go straight top, straight bottom. 9 times 4, 36. 1 times 9 is 9. 9 goes into 36 4 times, so we get a 4 right there. Okay. You can also do this, and I'll do it in a different color. You can also do 9 times 4/9 this way. Put it over 1 as you would multiply fractions. And when you have a number in the bottom of a multiplication of fractions and a number in the top of a multiplication of fractions that's the same, or that are factors of each other, like 9 can go into 9 1 time. So these divide to become 1. 1 times 4 is 4. 1 times 1 is 1, or 4. 4 over 1 is the same thing as 4, which we plugged in. Okay. So we do still inside those parentheses, so the 2 stays there. 4 minus 18, it's a negative 14, minus 12. So I'm going to go sideways now. 2 times negative 14 minus 12, that gets more negative, so negative 26. So it's going to be a negative 52. That's going to be our answer there. Okay, negative 52. Just got to work on those order of operations. On B, I'll do B in a different color because it's all kind of jammed. I'll do blue for B. We got the square root of something minus 3 times something plus 2 times something. Well, I put B in the square root part, and I put A 2/3 here, and negative 4 goes there. Exponents, well, a radical is on the same level as an exponent, So I'm going to do that radical first. The square root of 9 is 3. 3 times 3 becomes 9. And we've got negative. Now I can make that a fraction. There's a 3 on bottom and a 3 on top. They reduce to 1. So that leaves me with 1 times 2 is 2 over 1 times 1 is 1. 2 over 1 is 2. So I don't have to worry about that being a fraction anymore. And positive 2 times negative 4 is negative 8. 3 minus 2 is a 1. 1 minus 8 is negative 7. Okay. That's where we go with those. So even if they have 3 variables, 2 variables, 1 variable, as long as they give us what it is, we just plug it in that place. And if you use that parenthesis mode, you'll always have a hole to put something, put a number into, or whatever they tell you that letter is worth. You can always write it correctly, then follow order of operations. Okay. If you'd like, go ahead and pause, give yourself a second, and try these 4 problems. They give you the equation, and then the semicolon, and then they tell you what to plug in for the letters. And that's all you have to do. So push pause right here and give it a go. All right, now let's see if you got these correct. Hello, don't need that. All right, so let's try number 1. And go back to red. I'm going to shrink my pen just a little bit. Number 1. The square root, 2, erase the whole thing. 2, what does it mean if something is next to something else? Like if there's a number next to a parenthesis, or a number next to a square root, or a number next to a letter. Can you think of what that means? Okay. When they are next to each other, that is actually a time. So when we have the 2 times the square root, it's a multiply there. Okay, we'll do that near the end. We're going to put something in for m. We're going to add 31 to that. What we're putting in for m is the negative 6. We're going to do what's underneath the radical first. It acts like a parenthesis when there's stuff underneath it. Once that's done, then it becomes like an exponent level of stuff, so you'll do it second. So, excuse me, 2 times the square root of 25, because negative 6 plus 31, take away 6, gives you 25. 2 times the square root of 25 is 5. So the square root of 25 is 5. 5 times itself is 25. That's how we get that. 2 times 5 is 10. Where you should get there. Okay, let's look at number 2. I'll change color and go green this time. Number 2, 4 times something minus something. 4 times s is 3/4. T is 1/2. Well, I like this first one because when I do the multiply fractions, I got a 4 on top and a 4 on bottom. Those reduce to 1. 3 times 1 is a 3. 1 times 1 I don't have to put on the bottom because anything divided by 1 is itself. So 3 minus 1/2. Well, if I take a half away, I'm going to be less than 3, but I didn't go all the way down to 2, so I'm going to be 2 and 1/2. Or you might have 2.5. Those answers would work just wonderful. Okay. Change colors for number 3 here.